Good evening, everyone. Welcome you all to the Tech Gig webinar. Thank you for joining the session today. The topic of today's talk is Introduction to Blockchain and its Basics. It will be an hour session with around 40-45 minutes for the presentation and the remaining time for the Q&A. So if you have any questions, please send them to us using the question tab. I am Vedant, the moderator of this session, and it gives me great pleasure to introduce you to our guest speaker, Mike Peterson. Mike is a leading technology professional with over 30 years of technology and management experience, with an exemplary record of identifying and addressing business needs, taking ideas from conception to completion, aligning technology with corporate strategy, and leading large technical organizations through technical and culture change related to big data, analytics, cloud, and blockchain. So, without any further delay, let me introduce you all to a guest speaker. Over to you, Mike.
Thank you. Sorry about that, folks. Before I get started, I just want to tell you a little bit about Parkar. Parkar Consulting and Parkar Labs is a boutique technology consulting firm born out of Chicago and affiliated with the 1871 research startup incubator in Chicago. Our practice consists of a strong group of folks, over 170 strong, of consultants specializing in delivering integrated engineering solutions in product and data engineering to clients across several verticals such as telecom, retail, infotech, services, and healthcare. And behind that is we're backed by the 1871 community, and we have an R&D team at Parkar Labs in the 1871 facility, which we're pursuing niche technologies and emerging technologies such as blockchain, which we're talking about today, machine learning, artificial intelligence, and other security engineering, building cutting-edge solutions and creating a new offering that add value to a larger solution set. So with that, I think we'll get to into this. The agenda is an introduction to blockchain, its key concepts and components, types of blockchain networks, several of the blockchains that are out there, and some of the potential applications of blockchain. I wanted to talk about a couple things that have happened over the last several decades that led up to the notion and the implementation of blockchain. We'll talk about several of these concepts in the following slides, but they're very important to know how they originated and how they led up to this. A lot of this stuff was born out of digital technologies, and as things started, particularly in the picture world, when they started putting those out, and they wanted to make sure that they weren't being doctored or people were getting in. And so that's when people started using hash trees to start creating hashes that would protect the original digital asset that we wanted to protect. Soon after that, they got into adding to that the ability to do chain of evidence with digital timestamps, which becomes very important in the blockchain. The first notional implementation and idea that was put out there was originally called BitGold, which was a decentralized currency, using extremely complex cryptographic math algorithms to protect the assets that they were creating. That never got implemented, but the concepts were out there. About a decade later, the famous Bitcoin white paper that Satoshi Nakamoto wrote that described both Bitcoin on a blockchain. And that was where all this stuff really got going. And one of the things that happened soon after that was when Vitalik was working for Bitcoin, and he was trying to get them to recognize the broader applications of that. And one of those being, building a blockchain platform that other people could build applications. And they didn't want to do that at Bitcoin, so he went out and started Ethereum and put that on the open source. So these are all events that were important to what we're seeing today as the blockchain bursting onto the scene and getting a lot of momentum. Blockchain is a distributed ledger technology which uses a peer-to-peer network, and the data which is in there is immutably recorded. And this is the stuff that gives trust and assurance. And we'll talk about what that means. So let's talk about some of the key concepts and components of blockchain. So shared ledger is really what this is about. And the notion of a shared ledger is that I have pieces of that ledger distributed over a node-based distributed data network. And the reason to doing this is that some of the ledgers that you have that are in one place in sort of a client-server environment are easy to get to. But once you've created this shared ledger that is distributed and start applying some of these other techniques that we're about to talk about, you start to create a much more secure environment. The cryptography that is involved in blockchain is the private and public keys that cause secure authentication and are able to protect the transactions. One of the other key concepts in this is consensus. So as the blocks get distributed over the nodes, that each of those nodes that are part of the blockchain network have to agree that the transaction that was added is valid. And once it's valid and it's noted as valid, and that's called consensus. Another important thing about this technology is the ability to create smart contracts. So where Bitcoin uses a cryptocurrency, one of the great applications for this is creating smart contracts. And that's the ability to use the blockchain technology to do things like sell goods, to work in the retail space, and not just in the currency base. And then there's the notion of proof of work, proof of stake. And the proof of work is really the activity that's done, and I'm certain many of you heard about blockchain miners. And what they do is, as they go out and try to validate through very complex math various blocks that have been created, once they've validated that and created the consensus and then established the nonce or the hash that says this is a valid block, then that's called proof of work. So let's talk a little bit about the cryptography involved in this. And like all cryptography, the important thing is, what do I do to encrypt the information? And then how then do I have the keys to decrypt it? So there are two types of cryptography involved here: symmetric encryption with a secret key. And then what blockchain uses mostly is asymmetrical encryption, which has both the private key and public key combination. And we'll get into how those are created through the hashing. So in hashing, there's the notion of a hash code. And these are algorithms that are applied to data that create a result that is representative of the data that was created. Hashing techniques, of course, have used to avoid high collisions and used for indexing, searching, and information retrieval. Low or no collision using cryptography, also known as hash function, is what blockchain is based on. So the primary hashing algorithm is SHA-256. And in each of these boxes here, you'll see that there's some variation of the quick brown fox jumps over the lazy dog. And on the right is the resulting SHA-256 hash. All of them are the exact same length, but none of them are the exact same value. This becomes important later on in validating the hash that's been put into a block and relating that to its other blocks in the chain. But again, you can see here the examples of the changes that are implemented through the hash based on the differences in the various boxes. In box 2, there's a period that wasn't in the other one. In box 3, there's a misspelling of over, and in box 4, there's a misspelling of brown. And again, there's no way to relate the various hashes just from those minor changes. I mentioned before about a nonce. The important thing about the nonce is this is essentially the private key that satisfies the fact that that block is authenticated. And so where you will have two different hashes involved in a block, which we'll see in the next slide, it's as you've gone through and got the consensus and got authentication that the nonce is created and stored additionally on the blockchain. So in any of these things, there has to be a certificate authority and digital certificates that are used in identifying the public key. And that's in something like Bitcoin or in Ethereum, they're both public and private nature to the data that's stored in the blockchain. So anybody can view the information that's in there, and that's how the public key, you can view it as long as you're in the network and ability to use the certificate to view that. The part that makes it immutable is the hashing, which you have to know how to do to be able to change the data in it. So the certificate authority and digital certificates allow you to view it, and the hashing allows you to modify it. And here's the flow of how that works. You see the hash function on the data encrypting it, and it's combined with a certificate that allows somebody who is part of that blockchain network to view it. And those combinations, you attach the data to the digitally signed data. And then through the verification, you use the certificate to view the data, and then you decrypt, you use your private key to decrypt the data and view it in a way that then you can put the e-signature that is valid. So let's talk about the formation of a block and how we put all these pieces together. So all these things that we've talked about, you'll notice that the linkage between blocks, and this one points to the previous block n-1, it actually is the hash that was created from the previous block that gets, when the transaction is created, this gets pushed forward into the next block in the chain. You'll see that with each transaction, there's a digital certificate, and there's also a hash for the data that's associated with that. And the block signature is the nonce. And here we're creating a transaction, and you'll notice that the block signature is pushed forward to be part of the next block, and the transactions, and one of these might be the transaction that's pushed in that. If we did ABC and that's the transaction that we're working in, it would be carried over into the transaction in the block n+1. And once that's validated, then the nonce hash is added to that. There are multiple types of blockchains and ledgers that are out there. There's public, private, and hybrid. The public ledgers like Bitcoin are ones that are most prominent out there because a lot of people can see them, but not everybody can get to the information. There are a lot of nodes in these public ledgers, and that's the idea of them, is create as many people that are part of your blockchain network. So something like Bitcoin has well over 7,000 nodes. Something like Ethereum, I believe, has over 20,000 nodes at this point. And you can, have your own node, which the way the node networks work is that you offer up a computer to be part of that node. Then you try to get validated and certified to be part of that public ledger. And so then you get active in creating that large stuff. And the more nodes there are, the less chance there is of somebody hacking in or being able to breach that, because they'd almost have to simultaneously get to all the nodes before the nonce has validated the block. But of course that makes things slow, and because it's a lot of things that have to be validated. In a private ledger, it's often much faster, and it's within a closed network. So the private ledgers are not able to be seen by anybody in the public that has the digital certificates that would allow them to do that. So as you see, it's known participants from one ARG. There's write permission to centralize. Reads may be public or restricted, and multiple algorithms for consensus. And then, of course, there are hybrid ledgers. Ethereum is something that you can create as a hybrid ledger on your application, and it combines these two things. So when you want to be private, you want information that isn't shared to the public, then you can do that. So one of the things to keep in mind is there's a lot of people out there who want to go out and create their own blockchain. And they want to do have an ICO, an initial coin offering, and create their own cryptocurrency because they believe that the blockchain or the currency they're going to create is, create value in something. We see that the Bitcoin value, I think today, was close to 14,000. So the value is going up, and we all get excited about that. If you were to go out on coinmarketcap.com, you would see over 1,300 ICO-based cryptocurrencies that are out there today. The top 19, and maybe today is the top 20, have market caps over 1 billion. Of course, the market cap on all of these is really founded on the belief that there's value out there, because there's nothing behind these things. It is more the scarcity and more the number of people that are utilizing it, plus they think future uses to this. I think I was reading an article recently where they actually believe that the Bitcoin upside could be up to $200,000 a Bitcoin. The top 5 of these, and so if you go out and look at coinmarketcap.com and you look at the list there, the top 5 most valuable currencies, at least as of yesterday, was Bitcoin, Ethereum, Bitcoin Cash, Ripple, and IOTA. And you read a lot about those, but I think as you sort of scan down the list and see how many of these things are are available. And it also might, lead you to, rather than going out and creating your own blockchain, that you actually want to put your application on one of these, and some of these are very specific. IOTA is, of course, something that's geared towards IoT. Ethereum is for web-based type applications. So you can find ones that fit your desire without actually having to create the blockchain. However, if you're somebody who really understands cryptography and you want to use a different hashing mechanism, and you have that kind of skill, I would encourage you to go ahead and create your own blockchain. It takes some time, and then you have to decide, how you're going to get people to join into that and what's going to want them to join into your blockchain network. I also want to sort of talk about some of the other things that, have been coming out as beyond the sort of Satoshi type Bitcoin blockchain. In every public blockchain, there is the ability now to create block stack. And the notion of block stack is a component that almost creates a decentralized internet that uses the same type of cryptography to protect the nodes within the decentralized internet. So that's something that you should look into. Corda is an alternative distributed ledger technology using state changes and transactions instead of blocks and chains. So the notion of distributed ledgers is people are finding ways to do it outside of the standard blockchain, and again, they create different intent. Sawtooth is a Hyperledger project that is actually open sourced in Apache. So if you're somebody who utilizes other open source in Apache and know how to work within that context and want to contribute back to that and become a contributor, Sawtooth is something you would get involved in. There's also getting to be distributed cloud storage that is data storage that's based on blockchain technologies. And again, this notion of how you use cryptography and you use the consensus to protect information, not just in blocks, but in larger type storage things. This is what the distributed cloud storage is about. Digital identity, you're finding that one of the great applications for a blockchain is creating unique IDs that can carry the history of somebody, and these can be done related to medical records or schooling records or things that you're going to have over time that you want to track related to a single digital ID that you carry forward with you. Now, in some countries, and actually in most countries right now, there's no court rulings that would actually validate this and say, or rulings that would say that this stuff can be used in a dispute. So some of these things like decentralized notary and digital identity, they often have an identified third party because governments currently don't or haven't ruled on this in their judicial systems to say that this is something that's valid in a court case. And the other thing is when you're using some of these, you have to be aware of privacy laws within the countries that you're operating in, because in Europe, there's the notion of the allowed to forget rule. So where you have immutable data that you carry forward in a blockchain or some of these other implementations, in Europe, you have the ability to say, I don't want this information available to the public anymore. And at some point, there's going to be some contention about those things. So you have to be aware of, the areas that you're working in and how it deals with private data. Just some of the highlights on, what is blockchain capable of. It certainly saves time in settling transactions because, one, it's all digital, it's all electronic, but also you don't have to get ruling bodies or a third party involved because it's all done through math and through algorithms, and people participating in that. It reduces costs, overhead and costs, intermediaries, so you don't have that third party that are charging you transactions or middleman fees to do that. Of course, it reduces risk because of the consensus and the hashing, cryptography, and other things that are creating using those techniques to create the immutability and the protection of that data. It establishes trust because, interestingly enough, when you wander into this world, you take the approach that they don't trust me and I don't trust them. And so through that, once you've proved out and it's gone through the consensus and you have a group of people who are validating the transaction or validating the activity that's going on or the results of that, then you basically establish trust because it isn't subjective to a person's opinion. It's all math based. The other thing is, it is cross-border transactions. So at the moment, there are no government regulations, and this gives a lot of freedom in how you can do things. But like all things, once they become something that's making money or something that's widespread, the government will find its way into this. I think there's been some stuff that's happened in the U.S. As an example, where they've decided that things that are in a Bitcoin, if you own a Bitcoin, that it's an asset that can be taxed now. So I think this will be a little bit broader. And as more banks get involved with blockchain and they have private blockchains, and this gets something as a recognized currency or a recognized contract, again, you'll find governments getting more involved. And then maybe in the future, we won't have fiat currencies like the dollar or the pound, but there'll be a cryptocurrency that is the equivalent of that. I think, we should take a minute here and talk about, some of the possible applications and some of the applications that are being funded. At this moment, I think that blockchain is probably one of the most well-funded technologies out there. There are a lot of venture groups, a lot of private groups. There's consortiums being formed in each of these things. Insurance, you can imagine that it helps prevent fraud and risk protection. Of course, there are some things like carrying your medical history and creating a record that shows everything that you've ever been involved in. So insurance companies don't have to wonder, was it a pre-existing condition? Of course, that may not be good for the patient. Smart contracts, the authentic execution of financial letter and agreements without relying on intermediaries. This is one of the things that's happening a lot with this right now, is because you have something that is verified, and if you don't pay and something doesn't happen, there's protection to not remit that and not get burned on something because it's all done digitally. Again, healthcare, sharing patient EMR records, clinical trials. This is some of the things that Parkar is pursuing. Digital identity, employment verification, travel, trade, supply. So these unique IDs that can follow you and track. And so they're, instead of carrying a passport around or things that you may need for your travel stuff, all that stuff there, as well as in supply chain. This is being used a lot and will eventually be used in marketing and advertising, and people understanding your buying patterns as well. A registry, because blockchain enables timestamping and proof of existence, that there will be this ongoing ledger of people are using in different types of registries. Financial services is probably the biggest application right now, because this started out as something involved with cryptocurrencies like Bitcoin. So fintech is something that probably has more blockchain implementations going on, and some of the big banks all have their own initiatives. I think Bank of America, HSBC have really big blockchain initiatives because they see the value of that, and they're international, and it gives them a lot of things to help prevent fraud and hacking. Of course, IoT, because IoT are a lot of small transactions, and if you can build a blockchain that is aimed at being on devices, and there are some technologies out there right now that are small enough on the blockchain implementation that they actually can be on mobile devices or on other small IoT devices, and you can get those transactions and they can't be hacked because of the way they use the cryptography. And then of course compliance. And I think as more governments get involved with this, you'll see more of the compliance stuff. So again, let's talk before we get into the Q&A, talk a little bit about some of the key benefits. The virtual asset creation and distribution of immutable records. Again, this notion of immutability is the notion that once you've put something in a block and it has been validated and verified, it never can change. And if someone does go in and change it, you know, like we saw in the hashing, it immediately, in the various copies of that block around the network, that they won't all agree, and then it'll go through and have to be verified so that they can get rid of the ones that someone tried to hack in and change. The traceability of records, because you always have the hash that points back to the previous block. So you can, if it's not in a particular block chain that you're looking at, the miners and other people can find something and then go back and reestablish the linkage in the records and create that traceability. And again, because you know that it's immutable, you can trust that lineage of records that may show, as an example, how your address changed over time. The uses of algorithms to dynamically negotiate in real time. You know, so much of this, again, is based on some, you know, pretty interesting math because of the many types of hashing that you're doing in here. And there's actually some blockchains that even have more complex math involved with them. So again, this creates the ability that you have to use, you know, pretty specialized computers to create that hashing. And for the moment, this is a very secure way to do it because it's a very difficult hash to break, and other people are creating new and improved cryptography to use for their hashing. But we don't have the computing power right now to, in any a quick method, to go in and break those cryptographies. So that concludes the basic overview. And if we'll open it up for questions. So there's a question out there, as a carrier, how do I start learning or developing into a blockchain? So there's lots of ways to do this. Most of the major cloud providers are, you know, so if you're somebody who's used to, you know, working with AWS or Azure, and you know, IBM is big in this, that if you want to get an easy, quick tool set that you can go work with, and you know, it's an easy, like anything on AWS as an example, it's easy to go out there and look at the facilities they have, and just go out there and start playing with this. If it's something that you want to actually focus on developing your own blockchain and perhaps your own cryptocurrency, there is a lot of tools and training out there that's easy to get to. Certainly lots of books, and you could go to Ethereum, and the way Ethereum works, and is something that's easy to build on top of if you want to have an application. They have what they call the Ethereum virtual machine, and you're using specific downloads in there like you would, if you were doing Java, and you sort of do the same thing. You start downloading the code and then learning how to build applications in that. And in fact, if you're somebody who is a JavaScript developer, there's actually a blockchain out there, I think it's called Links, that is focused on people who that's the language that they know. But out in any of the sites that if you go to them, they have how-to guides, and they have applications that you can download to start developing your blockchain or to start leveraging a blockchain that's out there. And so there's lots of ways to do that. So there's a question in there, and this is a good question, is most governments, and this is one of the false things that they start talking about some of these cryptocurrencies, but you're right, most governments, most fiat currency has some sort of backing behind them. Often it's the backing of it may not be that they have gold or something that backs it, but there's a government there, and the government can also always raise taxes or do something to back that currency, and this is how currencies go up and down in the commodity market. But with these cryptocurrencies, there really isn't anything that is backing them. This is really a speculative market, and you're going to rise and fall the value of those things or how you use them, based on what people's perception of that value is. So there is nothing behind them backing them. Bitcoin, so far this year, it's gone from 1,000 to 14,000 today. That's just in 1 year. And a decade ago when it started, it was less than a penny. There's no real value there other than scarcity. I guess it would be more like a trading card. People want to buy a rookie card of some famous athlete, which has no value more than the paper that it's at. But because it's rare or somebody thinks it's going to have value, then, like art and other things like that, the value is purely a perceived value. So it's a risky venture. And if it goes down, nobody takes responsibility because it is, a risk in when you invest in these things. And there's no better way to say that, I guess. Yeah. So the difference between, someone's asking, what's the difference between blockchain and Bitcoins? So Bitcoins are the cryptocurrency that are the transactions that utilize the blockchain to, the blockchain is the underpinning technology that the Bitcoin is a cryptocurrency that, again, if you want to do something, some sort of contract, or you want to buy something, the transaction includes a value. You say, I want to sell something, I want to create a smart contract, here's the currency that I want to use, and I want, if you want to buy it, it's going to cost you 2 Bitcoins. And then the transaction does, the blockchain transactions do a couple things. One is they set up that contract, and when that's settled, that's what proof of work is. And one of the things that happens is there's also the validation that you actually have that currency, and that's called proof of stake. So these are the things that you're doing. So blockchain is a general technology type. A Bitcoin is a specific cryptocurrency. So that list I talked about before, they are blockchains and they have their own cryptocurrency. And there's a lot of different types that are out there. So the difference, someone's asking, what's the difference between a miner and a middleman? So the middleman is, essentially, if you want to do a private blockchain network, you may create somebody who is the authority that's verifying that. And that's sort of the way things are done today. You have a middleman who's the trusted third party that does that. The miners are part of the consensus network. So if you have all these people who have signed on to be people that help validate the information or certify the information and create that nonce hash. So it isn't a miner or one middleman who has responsibility for, verifying that contract. What you're doing out there is it's almost like crowdsourcing the verification and validation, and that's what mining is. So someone's asking, where's the scope of testing in blockchain? Well, I mean, this is something that's incumbent on the person building the blockchain. So when they do that, or when you create your own blockchain and your currency and your algorithms, or whichever ones you're using, there's a lot of stuff that you have to test and validate before people start to want to use that. And so there's going to be a lot of people who are out there looking at it, testing it, if they want to sign up. And it again becomes this sort of, you have to do the testing and you have to verify it works. But other people are going to quickly go out there and test that themselves if they want to use it. And where they start finding problems, that's going to be broadcast pretty broadly. Somebody's asking how many transactions are allowed in a block. They're really, in a lot of these, there isn't a limitation. Some of them don't have limitations. Some of them do because they're smaller private blocks and there's so many transactions. So sometimes in those situations, they'll go out and look at the transactions and collect them in a block before they go on to the next one. So there's a lot of variances out there depending on which blockchain you're using and the type of transactions and the size of those transactions. So there's just a lot of variance. There is no standard for that at the moment. So it says here, does private or hybrid blockchain require miners? And someone's asking what proof of stake is. So in the private blockchain world, you don't have, again, as much of this consensus because you have a designated point-to-point. So a private blockchain might be through all the branches of a bank. So they're not going to have miners. They're going to use technology to validate those things because it's in a closed network and only people with those private keys can get into it. So you don't have this notion of needing consensus and miners. It's really in the hybrid and public blockchains where you have miners, and in the hybrid it's really in the public side that you're using miners to do that, because their job, again, is to validate the information or the block that it's in the right place in the chain, or that the information there. And proof of stake, as we talked about before, is really this notion of validating that what currency or what asset you're trying to use in a transaction. Proof of stake is when that consensus has gone out and looked at it, that they validated you actually have that. Or if you're doing a smart contract will be designated that you're not going to release the purchase stuff or ship it until you've actually validated that the currency or the asset you're trading for actually exists. And when that is done, that's called proof of stake. So somebody's asking, can we store images and documents in blocks? And the answer is yes. There are specific blockchains and specific crypto hashes that actually work with images and larger documents. Now, some of these are starting to use sharding techniques because you have an image has a lot of information in it. So a lot of those type of blockchains will actually shard the information and maybe separate that into multiple blocks and then have a way to put that back together. So there are blockchains that can do that. You'll find that there's fewer of those, but they do exist, and I'm certain those are going to get more and more as time goes on. So I think that's the last question we're taking, at least that's what they're telling me. I want to thank you all for joining. If you have other questions, just send them along. You have my email, and I will try to get to those. Thank you very much.
Thank you so much, Mike, for this really empowering and motivating session today. I would also like to thank all our participants for making this webinar a great success. This session has been recorded and the recording will be soon available on techgeek.com. Thank you everyone for joining us. Thank you.